Hi guys. In this problem, we are asked to find the complement of a given integer. The complement of an integer is obtained by flipping every bit in its binary representation. This means that every 0 becomes 1, and every 1 becomes 0. Let's understand this with an example. Suppose the integer is 5. First, we convert 5 into its binary representation. 5 in binary is 101. Now we flip every bit. The first bit is 1, so it becomes 0. The second bit is 0, so it becomes 1. The third bit is 1, so it becomes 0. After flipping all the bits, we get 010. Finally, we convert this binary number back to decimal. 010 in binary equals 2 in decimal. So the complement of 5 is 2. The task in this problem is simple. We are given a non-negative integer n. We convert it into binary, flip all its bits, and then convert the result back to a decimal integer. That final number is the complement we need to return. Let's understand the problem using a few examples. First example. The input number is 5. First, we convert 5 into binary form. 5 in binary is 101. Now we flip each bit. The first bit is 1, so it becomes 0. The second bit is 0, so it becomes 1. The third bit is 1, so it becomes 0. After flipping all the bits, we get 010. Now we convert this binary value back to decimal. 010 in binary equals 2 in decimal. So the output is 2. Second example. The input number is 7. First, we convert 7 into binary. 7 in binary is 111. Now we flip every bit. Each one becomes 0. So the result becomes 000. Now convert this binary value back to decimal. 000 equals 0. So the output is 0. Third example. The input number is 10. First, convert 10 to binary. 10 in binary is 1010. Now flip every bit. 1 becomes 0. 0 becomes 1. 1 becomes 0. 0 becomes 1. So the new binary number becomes 0101. Finally, convert this binary number back to decimal. 0101 in binary equals 5 in decimal. So the output is 5. In this problem, we need to find the complement of a given integer. The complement means flipping every bit in the binary representation of the number. In other words, every 0 becomes 1 and every 1 becomes 0. Let's walk through the solution step by step. First, we handle a special case. If the number is 0, its binary representation is simply 0. Flipping this bit gives 1. So if the input number is 0, we immediately return 1. Next, we calculate how many bits are present in the binary representation of the number. We use the built-in method bit_length to get this value and store it in a variable called number of bits. For example, if the number is 5, the binary representation is 101, which has 3 bits. Now we create something called a bit mask. The bit mask will contain the same number of bits as the original number, but all bits will be 1s. We create this mask using the expression 1, number of bits, 1. For example, if the number has 3 bits, the mask becomes 111 in binary. Finally, we compute the complement using the XOR operation. When we XOR the original number with the mask, each bit flips automatically. For example, if the number is 101 and the mask is 111, the XOR result becomes 010. That is exactly the complement we want. So the final step is returning the result of number XOR bit mask. This solution is very efficient because it works directly with bits instead of converting numbers to binary strings. Let's run the solution with a few examples. And yes, the test cases passed successfully. After testing the code with multiple inputs, we submit the solution. The code passes all the test cases successfully. That's it for this problem. In this video, we solved the complement of base 10 integer problem using a simple bit manipulation technique with XOR and a bit mask. This approach is clean, efficient, and runs in constant time. If this explanation helped you understand the concept of bitwise complement, make sure to subscribe my channel. See you in the next video with another daily LeetCode solution. And guys, I've given the solution link in the description.